Okay, so today we're gonna focus on the cosine law. Um, so again, yesterday well, in yesterday's class you hopefully kind of like understood how sine law works. So one way of thinking about the difference between cosine and sine law is that when your sine law fails you, then your cosine law can come in handy. Okay. Um, both of them, I mean, aren't that difficult to use, I guess, but the sine law is more straightforward because the algebra is much nicer because all you have to do is just cross multiply, okay? But when it comes to cosine law, your algebra skills have to be um, a little bit, I guess, a little better, okay, a little better. And I know that you guys, your algebra skills are somewhat average, so this might give you a hard time. Not because the law is difficult, but because your algebra might let you down. Okay, so um, and it might take slightly longer to solve a problem using cosine law as opposed to sine law. So what I did as a student was I always tried solving the question using sine law, and when I realized that sine law would not work, that was a good indication for me to use cosine law. But I tried avoiding cosine law as much as possible because it was a little bit more time consuming. Okay, so before we talk about cosine law, let's kind of like review when can you use the sine law. Okay, so let's say this is your triangle. So something like this. Okay, so this is A, this is B, and this is C. When can you use sine law? So if you know what angle A is, and let's say you know side A, right, which has to be opposite to the angle. So this will be side B, this is side C. And you know side A, right? So you need to know an angle and the side opposite to that angle. And something else, okay? It could either be, let's say, if you know what your angle B is, okay? Knowing an angle is actually better than knowing a side, because if you know what angle B is, right, then you can also figure out angle C using the fact that C will just be 180 minus A plus B. Okay, so knowing an angle is actually um, um, a, a more crucial piece of information. Okay, but let's say if you don't know what angle B is and you know what side B is, okay, then you can't really do much when you know what side B is. The only thing that you can do is you can figure out what angle B is, right? And then using that, you can figure out what angle C is going to be, and then you can find side C. Okay, so knowing the side is gives you a little less information, but you can apply the law twice and then figure out what you need to figure out. Okay, so this is a situation where it works, right? So you need to know an angle, a side opposite to it, and something else. Could be an angle, it could be a side. It will work. Okay, I guess a better question is when will sine law not work? Okay, so I'm going to give you a situation where the sine law will fail you. And there's actually two situations where the sine law will fail you, and that's when you'll have to use cosine law. So if you have a triangle, for example, that looks like this, okay, so um, and let's say you know the length of this side. So let's say this is um, 3, okay, and let's say this is 4, and this is 6, okay. Now, you cannot really use sine law over here because for you to use sine law, you need a side and an angle opposite to that side. But here, you have all three sides, okay? You have none of the angles. So the cosine law will help you find one of the angles. And you can find either one of them using this information, whichever angle you want. Okay, so this is a situation where sine law will fail, okay? So sine law will fail. So this is one situation. Another situation where your sine law can let you down is if you have a triangle, let's say something like this. And again, let's just go with Um, you know what? Let's just go with whatever. Let's say 5, 5, 12. And this, again, we're talking about um, arbitrary triangles, right? So they're not right angle triangles. So your Pythagorean theorem cannot solve you, right? Because this is not a right angle. Even though it looks like one, let's just suppose that it's not, okay? So let's say you have a situation where you know two of the sides and the angle, let's just call this angle 89, okay? So very close to 90, but it's 89, so your Pythagorean theorem will not help you. So in this case, you can't use sine law, okay? Even though you have a lot of information, you have two sides, um, and you have one angle, but you cannot use the sine law because you only know one angle. Okay, for you to use the sine law, you need to know what the side opposite to that angle is, but you don't know that, so you can't have a ratio set up for you. Okay, so this is a situation where sine law will also fail. Okay, so when you have side angle side and the angle has to be in between two of your sides, sine law cannot work, okay? Because again, for it to work, you need an angle and a side opposite to it. Here, even though you have a lot of information, you're missing um, the crucial piece of information that you need for this to work. Okay, so you have 12 over here, right? So if you knew what this angle was, you could have used sine law, but you don't know that angle, right? You have 5 over here. If you knew what this angle was, you could have used sine law, but you don't know what that angle is, right? And same thing over here. You know what this angle is, but you don't know what this side length is. So sine law will not work. And these are the two situations where you have to use cosine law. Okay, so this is situation one. If you want, situation two, sine law will not be able to save you over here, and you will be forced to use cosine law. Okay, so now let's talk about cosine law. So again, same thing, you know, in terms of labeling the triangle, right? Your corners will be ABC. The side opposite to your angle will have to be the same letter, right? And it's just a smaller case. Okay, so if this is angle B, then this side, the side opposite to that has to be B. Okay, and we're using smaller case letters for sides and uppercase letters for angles. Okay, so think of the cosine law, okay, as a stronger version of the Pythagorean theorem. So as you can see, you have c squared is equals to a squared plus b squared. So this looks kind of like the Pythagorean theorem, but then you have this extra term. Okay, you have this extra term of minus 2ab cos of c. Okay, so why do we have this extra term? Because remember, this will work for any triangle, okay? Now, if this happens to be a right triangle, right? So if this is your A and this is your B, and the angle in between is 90, okay? If the angle in between is 90, then you can use the Pythagorean theorem, but the Pythagorean theorem will automatically appear because C, right, your angle C over here, angle C will equal to 90 degrees. But if you use your calculator, remember cos of 90 is 0. So this will just disappear. Okay, so it's kind of like the Pythagorean theorem, but it is a stronger version of it because it will work for any angle, not just 90. But if the angle happens to be 90, then this extra term will just cancel out because cos of 90 is just 0, right? And if cos of 90 is 0, then that means minus 2ab times 0 will just become 0. So this will just disappear, okay? Now, again, there are a few things that I want to point out, okay? So, um, for this to work, you need a side and um, so you need two sides and an angle between the two sides. Okay, so when you have side, angle, side, then you can solve for the side that's opposite to that angle. Okay, so how do you do that? So c squared, right? So you don't know what c is, but in this case, you need to know what a is, you need to know what b is, and you also need to know the angle c, which is obviously in between sides a and b, as you can see in this picture. Okay, so you you need to know what A is, you need to know what B is, and you need to know what angle C is for you to compute um, C, okay? For you to figure out what C is. So you need all this information, okay? Um, but this it depends on how you label your triangle. So if you label your triangle in the right way, right? If you're assuming that C will always be your unknown, which it can be if you set it up that way, then you can just use this formula. But what if your triangle is set up in such a way that you're not looking for C, you're actually looking for A? Then the formula is the same, okay? So um, see, they're asking you to notice a pattern over here. The pattern is when you're trying to figure out what the C value is, then this C value and the angle have to be the same. If this is C squared, then this has to be angle C. Just like this is A squared, this is angle A. Okay, this is B squared, this is angle B. And everything else will be the other letters. Okay, so if this is B squared, then this has to be the letters that are not B. So it will be A squared and C squared, right? They're not B. And then you're going to have to do minus 2AC. Again, the same two letters will appear over here. Okay, so that's kind of like the pattern. And you can use any of these formulas. Um, depends on how you set it up, right? So if you set up your triangle in a nice way, then you can always get away with just using the top formula. But if the triangle is already set up for you, then it will force you to use these formulas, which will obviously be given to you. I think on the test, they usually just give you one, and then you kind of have to derive the other two by looking at this formula, right? So the pattern is really easy, right? If you change this letter C squared to A squared, let's say, then your angle will change from C to A, and everything else will be the other letters that you don't see up here. Okay, so if this is C, then these letters have to be A, B, A, B. Okay, if this is A, then this has to be B, C, B, C. Okay, so that kind of is the pattern. Okay, so again, think of it as the generalized version of the Pythagorean theorem. So it's yeah, I guess it's a stronger version of the Pythagorean theorem. Okay, so let's apply this. Okay. So again, a long question. I'm not going to bore you with the details, but what's happening over here is that this surveyor is starting at point A and then traveling to, let's just call this point B, and this person is also traveling to point C, okay? And based on the information, the distance between A and B, so let's just use it's 468.2, 468.2. And then the distance between A and C, I'm just labeling this point as C. You could, because they're using point A, right? So I'm just picking the other two letters that come after E. You could have chosen whatever letters you want. Um, then this distance over here is 692.6, right? And they are asking you determine the length of the swampy area. So they're asking you to figure this distance. Okay, so remember, if this is A, right? Then the side opposite to that has to be A. So they're asking you to calculate A. So if this is B, right? This is angle B, then this has to be small b. And if this is angle C, then this has to be small c. And what you also have is they are giving you the angle, which is 78.6. Okay, so angle A is also given to you. So you can read the question and come up with this picture on your own. Okay. So this is what the picture looks like, and like I showed you in the starter question. Okay, cosine law will work when you have side, angle, side. Okay, so that's one of the situations where cosine law will work, or if you have all three sides, okay, and no angle. So because you don't know what A is, you're gonna start your formula with A squared. Okay, so A squared is what you're looking for, will equals to, just like the Pythagorean theorem, okay, B squared plus C squared, right? So um minus 2, these letters will repeat. So B, C, cos of the angle, and this will always match. Okay, so if this is a squared, then this has to be a. So this is the formula. Not too difficult to remember. So it's kind of like the Pythagorean theorem with this extra piece of information, okay? So if you, so let's just verify this because this has been it's been a long time that I've actually used this formula. So let's see if I have the right one. Okay, so b squared plus c squared minus 2bc cos of 8. Okay, so this is the one that I'm using, b squared plus c squared minus 2bc cos of 8. Okay, so I do have the right one. Okay, now all you have to do is just plug in values and then solve for a. So this is not difficult. Um, the tricky part is when you have to solve for the angle. Okay, this one is not too difficult. So um, I know that B, so it's just a little messy. So B is 692.6. So this will be 692.6 squared. Okay, plus this is C, right? So C is 468.2 squared minus 2 times 692 .6. And I'm just going to continue underneath because I'm running out of space. So this is B, right? This is B, and now I have to figure out what C is, and it's given to me. So C, so times 468.2, and then times cos of A, so cos of 78.6, okay? And then just crunch everything into your calculator, okay? So just do 692.6 squared plus 468.2 squared minus 2 times 692.6 times 468.2, and then finally times cos, make sure you are in degree mode, 78.6, okay? And when you do that, you will get a big number. So remember, a squared will equals to this big number, right? Because we started off with a squared, and that big number is 5, so 570,715.2054. Okay, and then just take the square root of both sides. Take the square root of that, take the square root, and then a is what you're interested in, will roughly equals to. So square root of my answer is 755. Determine the length to the nearest tenth of a meter. So zero point 0.5. Okay, because I'm getting 0.45. And it obviously your units have to match, right? Because if this was given in meters, this was given in meters, then this has to be meters. Okay, so that's how you use the cosine formula. Again, if you're looking for a, then your formula has to start with that value that you're looking for. Okay, so that's how you know which of the three formulas you have to use. Okay, so because I was looking for a, my formula has to start with a. Okay, um, but if the picture is not given to you, then you can draw your picture in such a way that whatever you're looking for is C. Okay, then you can set it up that way, but it's not too difficult, like I said, to remember the formula. So yeah, so let's do the next one. Okay, so so you try. Okay, try using the formula. So read the question, pause the video, read the question, and try doing this. Okay, draw the triangle. The information is given to you, and then compare your answers with what I have. Okay, so Nina wants to find the distance between 2 points A and B on the opposite side of a pond. She's located at point C. So she's at point C. Okay, that is 35.5 meters from A. So if this is C, let's just call this A. Again, you know what? Let me just not make my triangle too big, okay? Because then it causes me a lot of problems. So this is C, this is A. So this has to be B, right? And now let's use the information. So that means this is small c, this has to be small a, and this has to be small b. Okay, so let's see, what do I know? So point C, that is 35.5 meters from A. So the distance between A and C is 35.5. So I'm gonna put 35.5 over here. And then she locates at a point C that is 35.5 meters from A and 48.8 meters from B. So the point C is 48.8 meters. If you want, you can put your units here. Um, from So point C is 48.8 meters away from point B. And now I see, for cosine to work, right, you need side, angle, side. So obviously this angle should be given to you. So let's read the question. If angle C is 54, right, so this is when you know that you have to use cosine law. Now, see, in today's class, sorry about that. So in today's class, I think I need to drink some water. So in today's class, you will always have to use cosine law, okay? But on a test, we won't tell you if you have to use sine or cosine. Okay, so you will have to determine that on your own. Okay, so like I said, cosine works when you have a side, angle, and side. Okay, that's when you know you have to use cosine, or if all the three sides are given to you. Okay, um, sine will work when you have a side and the angle opposite to it, plus something else. Okay, so I try to see if I can use the sine law. But when I see that I can't, that's when I use the cosine. Okay, that was my strategy when I was in high school, because sine is faster, in my opinion. Anyway, so determine the distance AB. So determine the distance between the points A and B. So they're asking you to determine C. Okay. So because C is the unknown that I'm looking for, that means my cosine formula has to start with C squared. So C squared is equals to A squared plus B squared. It will always be A squared plus B squared. Okay. And then, so kind of like the Pythagorean theorem, but then you'll have to remove this B. So it's going to be 2, and then these two letters will repeat, right? A and B. So minus 2A times B. Because it's the cosine law, this has to be cos, right? And because this is C squared, this has to be C. Okay, so this has to be C. So let me just remove this from here. And now you have your formula. Okay, but let's just check. So a squared plus b squared, right? This one, a squared plus b squared minus 2ab, and then cos of c. So I do have the right one. Okay. Now, plug in what you know. So, you know what? Yeah, I think I should have enough space this time, but just in case, I'm gonna put my equal sign over here, okay? So a is 48.8, so you square that. B is 35.5, right? And then you square that, minus 2 times A. So A is 48.8. Again, I'm getting these values from my picture, right, that I've drawn. Times B, which is 35.5, and then cos of C, right, again from the picture, 54. Okay, so just crunch this into your calculator. So C squared, now I can actually move this a little bit to the middle. So C squared will equal to whatever your calculator spits out when you punch everything in. Okay, so let's do that. So 48.8 squared plus 35.5 squared minus 2 brackets 48.8 bracket. You could use brackets or you could just do times. It's the same thing. And then times cos of 54. Just make sure that your calculator is in degree mode, okay? So c squared will actually equals to 1605.131658. I'm just going to ask you to just, carry all the digits because this is not your final answer, okay? So now you're going to have to take the square root of both sides to solve for c, and then c will approximately equals to the square root of this digit, or and it gives you, so what does it tell you? So to the nearest tenth of a meter. So I am getting 40.1 meters. Okay. So that's how you use the cosine law. Now, right, so remember in the starter question, I showed you that there's two situations, right? Either you have side, angle, side, or you're gonna have all three sides and they'll ask you to find the angle. So this is where the algebra gets a little bit messy. Okay, so the other two questions that I have for you will test you on that. Okay, so again, a lot of information, but all three sides of my triangle is given to me, right? Suppose one base has side 14, determine the measure of the angle, so whatever, right? So draw your triangle. So let's just draw this like a right angle triangle. Okay, so something like this, oops, something like this, then that, and let's say this is your longer side. So let's just call this 14. So this has to be 19. This is my longest one, and this is 12.2. Okay, so now what are they asking me? They are asking me to determine the measure of the angle opposite to the 14-meter side to the nearest degree. So they're asking me to calculate for this angle, okay? So because they're asking me to calculate for this angle, what I'm going to do is when you're given a situation like this, go with the the formula that might be the easiest one for you to use. Okay, so maybe this one. Okay, this is what I'm going to use because this kind of looks like the Pythagorean theorem, so it's really easy to apply this one. Okay, so which means so I know you might be thinking that this is C, right? Because it's the longest side. I mean, you could pick whichever formula you want to use. I am just gonna call this um again, it's up to you. Okay, so however you want to do it. But if you're so used to the Pythagorean theorem, then let's change the question. Okay, so I'm not gonna do what I used to do, so I'm just thinking like a student now. Okay, so let's say you're so used to this being C, and you're probably calling this A, and this is your B. Okay, so this is how you're accustomed to setting it up. So if you're setting it up this way, then this forces you to, so if this is B, right, then this has to be angle B. If this is A, then the angle opposite to that, so this has to be A. If this is C, then this has to be angle C. Okay, but you see, what you're interested in is angle B. Because you're interested in angle B, you're gonna have to start your formula with this B squared. Okay, so whatever you're interested in, make sure you start with this. But you're not actually solving for B, but because you're starting with B squared, your formula will end with cos of B, right? Which is why I'm asking you to start with this. Okay, so anyway, let's just erase this. So I know that B squared is equals to A squared plus C squared minus 2AC, okay, because they will repeat. And then let's use a different color. So cos of B, okay? Now you see, my goal is to solve for cos of b. So this is where the algebra gets messy. Okay, so how do you do algebra again? You have to do BEDMAS in reverse direction, okay? Because you know what b squared is, right? You're not interested in this value. You're interested in this, kind of like what you started off with. So you have to work backwards, okay? So what does BEDMAS tell me? Okay, BEDMAS tells me that I need to get rid of addition and subtraction first, right? So addition and subtraction have the same priority. Okay, so maybe let me use a different color. So addition and subtraction first, followed by multiplication and division, okay? My goal is to solve for cos b. So what that means is I need to get rid of addition and subtraction. So this is multiplication, right? 2 times a times c, this is multiplication. I can't really get rid of that, okay? Because that's multiplication. So what I can get rid of is this a squared. So because this is plus a, right, it's positive. So minus a squared. I'm going to do minus a squared, and then I'm going to do minus c squared, right? So same thing over here. So this will just become b squared minus a squared minus c squared. So they cancel out, and that leaves me with minus 2ac and then cos of b, right? So I got rid of addition first. There was no subtraction, right? Now I need to get rid of multiplication, okay? So again, my goal is to solve for cos of b. That means I need to get rid of these guys, okay? Because they're being multiplied, I can just divide it out, okay? So I'm going to divide this by minus 2ac, right? So divide this by minus 2ac as well, because when you divide by minus 2ac, they will just cancel out, right? So that means that cos of b, right? So now I have cos of b is equals to b squared minus a squared minus c squared minus 2ac, okay? And now just plug in your values. So what is b? Based on the picture, it's 14 squared minus a, based on the picture, is 12.2 squared minus c is here, 19 squared. And then you have to divide this by minus 2 times a, which is 12.2, and then times c, which is 19, okay? So again, running out of space, so I'm just going to put my answer over here. So let's work this out. So we have 14 squared minus 12.2 squared minus 19 squared equals, so you're going to have a negative number. Divide that negative number by minus 2 times 12.2 times 19, and then it will become positive, okay? So you're going to get 0.676 96, let's say, okay? But you're not done, right? Because your goal is to find angle B, not cos of B, right? So angle B will then just equals to the inverse cos of this value. So 0.67696, which will approximately, so to the nearest degree, okay? So to the nearest degree, so this will just equals to, so let's do that. Cos inverse of 0.67696 gives me 47 degrees, okay? So 47 degrees. So like I said, the algebra is tricky, but if you kind of understand how BEDMAS works, then hopefully this kind of makes sense. So what I'm going to ask you to do is practice your algebra by solving this question now. Um, and then compare your answers with me, okay? So yeah, so just that's why COS, like I said, is a little bit more time consuming because it really tests your algebra skills, okay? So let's pause the video, do this question, and then let's see if you kind of understood how the algebra worked. Because I'm pretty sure everything else kind of made sense to you except for the algebra part, right? Which will come with practice, okay? So again, I we have a triangle. So I'm gonna again just kind of like draw this like um, a right angle triangle. So suppose this is 18, this is 14, and this is 22. Determine the measure of the angle opposite to the side that is 18. So they're looking for this angle over here, okay? So again, guys, do this however you want, right? So if you are, you know, reluctant to change your values, then you can always consider this to be your A, this to be your B, this to be your C. And if that is the case, then because this is B, right, then this forces this angle to be capital B, right? Um, and that's all you need at this point, right? So I mean, if you want, you can label this A, you can label this C, but you don't really need that stuff, okay? So because I am looking for angle B, my formula will have to start with B squared is equals to A, right? So you have to start with B squared, okay? Because that's what you want, right? The B value, and then at the end you're gonna have cos of B, right? So that's the trick. So let's start over again. So B squared is equals to A squared plus C squared minus 2A times C, and then cos of B, okay? So now you're gonna, right, using BEDMAS, you have to get rid of your addition and subtraction first before you take care of multiplication and division, okay? So again, there's many ways of doing it, okay? Um, if if it really bothers you, what you could also do is move things over. So maybe let me show you a different method and then you can go with whatever you want. Okay, so because I have a negative over here, I'm actually going to move this over to the other side, make it positive, right? So this will just become 2AC cos of B, and then the B squared still stays here, right? So plus B squared is equals to A squared plus C squared, right? And then you can remove this B squared, so minus, let me use a different color maybe, um, minus B squared, minus B squared. So in this formula, you're gonna have less negatives. So now you have, but it's the same thing, okay? So 2AC cos of B is equals to A squared plus C squared minus B squared, and then just divide by um, 2AC and divide by 2AC. So then you will have cos of B is equals to A squared plus C squared minus B squared over 2AC, okay? Now this looks slightly different than what I initially had, right? What I initially had was this. Um, but you see, because there's a minus sign over here, I can actually bring the minus sign on top to make my denominator positive, which will make this positive. All your negative values will become positive, and your positive value will become negative, okay? Which is kind of what I have down here. So my A and C are positive, my B is negative. My A and C are positive, B is negative, okay? So it's the same thing. Maybe it looks a little nicer down there. So, you know, again, I wasn't the one who taught you algebra, right? So I don't know how you would like to do it, but if you want to move things over, right, like I did over here, that could also work, right? So, um, but it doesn't matter, okay? So once you get to this point, it's just a question of plugging in values, okay? So, um, so let's do that. So what is my A value? Based on the picture, right, it's 14. So 14 squared plus 22 squared minus my B is it 18? Can't really. Okay, yeah, it is 18 from here. Okay, so I didn't want to take any chances. So minus 18 squared, and then just divide this by 2 times what is A? A is 14 times C, which is 22. Okay, so A is 14, right? From this picture, C is 22 from here. And now, right, once you kind of like solve for that, so let me be consistent with my colors. So that means cos of B will equal to whatever this simplifies to, right? So 14 squared plus 22 squared minus 18 squared equals divide by 2 times 14 times 22, okay? And then you're gonna get an ugly number, right? So I am getting 0.5779. Okay, 4 digits I think is enough, and then the angle B will just equals to the inverse cos of this value, right? So inverse cos of 0.5779, and they're asking me to calculate this to the nearest degree. Okay, so I can just put an equal sign. So cos inverse of 0.5779 will equal to 54.6, so 55 degrees. Okay, so as you can see, cos, again, not bad, right? It essentially boils down to the starter question. These are your two cases, right? So it's either going to be um, side angle side or side where you'll have to find an angle. So one of these two cases. Otherwise, use sine law. And when you're finding, when you have side angle side, the algebra isn't bad, right? But when you have side, and you have to solve for the angle, then the algebra is a little bit more involved, okay? But I've shown you two ways of doing it. Go with whatever you find it easier. So for homework, guys, I'm not giving you a lot of questions, so just do these 3 questions, and that should be enough. Um, on Wednesday, I will hold a conference to answer questions. So it would be a wise thing to do the practice test. So just again, not that many questions. If you could get this done by Wednesday, it would be awesome because then you would be able to ask me those questions, right?